In the last part of lesson 8, we're going to extend what we did in the second part of lesson 8. We had pharma company using a decision tree to decide if it's going to bring a new product to market. In this part of lesson 8, we're going to extend the problem to include another layer of uncertainty. In the second part of lesson 8, there was only one layer of uncertainty, and that was whether the economy was going to be great, fair, or awful. We're going to continue that here, but we're going to add a layer of uncertainty regarding FDA approval, 0.193. Now, at the present time, pharma company can complete the development of the new product, which will cost an additional $5.96 million, or abandon it. If it proceeds with the product, the FDA can reject or approve Pharmaco's new drug. If the FDA gives its approval, Pharmaco has budgeted $4.08 million to bring the drug to market and market it. If the FDA approves the product and the company decides to market the product, these fixed costs can be offset by an expected unit margin of 17.99. That's price above cost. According to a survey of economists, the probabilities of economic growth being great, fair, or awful over the next few years are 0.448, 0.351, and 0.201, respectively. Industry analysts expect the firm's sales volume to be 609,000 in a great economy, 297 units in a fair economy, and 89,400 units in an awful economy. Now, we're going to build the decision tree and the spreadsheet model in cells A1 to D17. And what you want to do is you want to copy this format. I've already done that here. And then I give you an outline at the top here of the various stages. In the first stage, the company has to decide between proceed and market it or abandon it altogether. You can assume that they've already spent some money, right? And at this point, the money they have spent is sunk. So it doesn't enter the decision at all. Because they spent it if they decide to proceed. They've already spent it if they abandon. So we can ignore what they have spent up to this point. The uncertainty follows the decision of this first stage. FDA approves, FDA rejects. And then, based on getting FDA approval, they can market it or shelve it. Now, if they get an FDA rejection, they're done. They're not going to market a rejected FDA product. But if they get the approval, they can market it or they can shelve it. Now, why would they shelve it? Well, maybe the amount of money they can earn while the patent is valid, maybe it doesn't exceed the marketing cost. So they may decide to shelve it. If they decide to market it, then they face a second layer of uncertainty. The economy will be great, the economy will be fair, or the economy will be awful. Maybe you can use that to envision what this decision tree is going to look like. I'm going to fill in my spreadsheet model. The probability of a new drug under development failing to secure FDA approval equals 0.193. We're going to put that right here. So the approval must be 1 minus that, right? The fixed development cost is $5.96 million. We're going to enter that as a negative number. We also need to get rid of the commas. We're going to enter it as a negative number because it's a cost, right? The fixed marketing costs are $4.08 million. Again, we're going to enter that as a negative number in our model because it's a cost. The unit margin in my model is 17.99. The probability that the economy is great is 0.448. The probability that the economy is fair is 0.351. And the probability that the economy is awful is 0.201. Sales volume, if the economy is great, is 609,000 units. Sales volume is expected to be 297,000. Sales volume is expected to be 89,400 if the economy is awful. Now, to get the gross margin, we did this in the second part of lesson 8. It is equal to the unit margin times the sales volume. Now, because I'm going to copy this down, I want to fix the blue box in row 12. So I'm going to put a dollar sign between the B and the 12. And then I can drag this down. Now I'm going to enter these values in my table here to verify that I'm doing it right. While I'm doing that, pause the video, fill in your table with your values, and then resume the video when you're done. All right, welcome back. It looks like we got all these correct answers. So we can move on to building the decision tree. Now, to build the decision tree, you want to put it in cell F1 according to the instructions. And we're going to use the BY tree plan macro that we installed into Excel. In order to access it, you have to click on tree plan, and you want to click new. And in the first stage, we have 2 branches for our first stage decision. So we're going to click on with 2 branches. I'm going to click on decision 1, press the equal sign, and then click on proceed. I think what I'm going to do is I'm going to abbreviate. I'm going to change that to just proceed with a product. I'm going to click on decision 2 and then press equals and then click on abandon. Part of proceeding is have a team of lawyers and the firm submit their application to the FDA. All of that activity is included in this fixed cost. So right below proceed, there's a 0. I'm going to press equals and then click on the fixed development cost. Then I'm going to click this cell here. I'm going to change it to an event with 2 branches. Event 1, I'm going to click on it. I'm going to type equal, and then I'm going to click FDA approves, press enter. On event 2, I'm going to press equals and then rejects. The probability of approval is 0.8070. The probability of rejection is 0.1930. This is 0. It's going to remain 0 because we're including the cost of submitting our application and all the lawyer fees associated with it. We're including that in this cost. So we can leave this at 0. Okay, so suppose the FDA approves. Then what's going to happen? We have to make a decision. Are we going to market the product, bring it to market, or we're going to shelve it? We'd shelve it if the gross margin we expect to receive from it doesn't exceed the marketing budget. So right here, we're going to turn this into a decision with 2 branches. Decision 1, I'm going to replace it with equals. I'm going to click on market it. Decision 2, I'm going to press equals and click on shelve it. Now, if we shelve it, we're done. We're not going to spend any money on marketing the product or set up distribution. We're not going to do any of that, right? We're also not going to get any sales from it. right? So we're done with this branch. If the FDA rejects it, we're not going to proceed. We're done. If we abandon it, we're done. So all these branches are terminated. However, if we market it, we could have three events: a great economy, a fair economy, or an awful economy. So I need to click and change that node to an event with three branches. And event one, we're going to replace event one with great economy. We're going to replace event two with fair economy. We're going to replace event three with awful economy. If we market the product, we have budgeted a bunch of money to bring the product to market and to market the product to consumers. If the economy is great, we expect our gross margin to be that value for a great economy, right? Let me widen this up. The probability of a great economy is 0.4480. The probability of a fair economy is 0.3510. We expect a gross margin for a fair economy of $5.343 million. For an awful economy, the probability is 0.2010. And we expect a gross margin of $1.6 million. All right, let me reduce the zoom to 100% so we can see it better to auto fit it. Also, I want all the dollar values to be 0 decimal places. I want the probabilities all to have 4 decimal places. How do we get this value here? All we're doing here is we're taking this cost, adding it to that cost. So our total fixed cost minus our expected gross margin for the situation where we have a great economy and FDA approval. This is doing the same thing, but for a fair economy. That's our expected gross margin. That's what we're going to spend on marketing. And that's what we're going to spend on proceeding with developing the product. This value here is the same for an awful economy. This is what we expect our gross margins to be. This is the cost of marketing the product, and this is the cost of proceeding with development. These two are identical because on this branch, we spent the money to proceed. And on this branch, we spent the money to proceed. Here, we don't do anything after the FDA rejects for obvious reasons. Here, because we shelved it, we don't need to worry about whether the economy is great, fair, or awful. We're going to generate 0 revenue from a product that's been shelved. This value here is the expected value of net incomes. And then they're associated with the probability. This one is associated with that probability. This one's associated with that probability. This one's associated with that probability. So essentially what this box does here, all that right there is saying is some product, right? We're taking the product of U1 and V4, U6 and V9, U11 and V14, and then we're summing. And then this right here is just the maximum of these two. And the maximum is a negative number. So what this is saying is we want to market it. I mean, even though we expect a negative $2.9 million loss, at least we've recouped some of our fixed cost. Losing that much money is better than losing all of these development costs in stage 1 of our decision. So this is just saying, pick the one that with the maximum value, right? So we're going to market it if we get FDA approval. And this down here is the sum product of these two and these two. So what's going on here is we're multiplying M11 and N14. We're multiplying M21 and N24, and then we're summing. So this is the expected value of this result and that result. This has a probability equal to 0.8070, and this has a probability of 0.1930. And then down here, we're going to compare this to 0. And since 0 is bigger than negative 3517275, we're going to abandon the product. We're going to use our tree to answer these questions. If the company develops a new drug and gets FDA approval for it, for a great economy, net income is what? This is the gross margin. That's the net income for a great economy. So let's copy that. Put it here. For a fair economy, it's that value. For an awful economy, it's this value. Its expected net income of launching the new drug equals what? Well, that's this value here, right? The probability of this occurring is 0.8070. If the company develops the new drug, but does not get FDA approval for it, its net income would be what? The development cost, right? Whether that's a great economy, fair economy, or awful economy. And the expected net income of this outcome is that value as well, right? So if I multiply this by the probability of great economy, I multiply this by the probability of a fair economy, and I multiply this by the probability of an awful economy, I can factor this number out, sum the probabilities, I get 1, and then I multiply this by 1, and that gives me the expected value. Now, the probability of this occurring is 0.1930. Now, because Pharmaco, they can continue to develop the product, and then they can market the product, or they can shelve the product, or in first stage, they can abandon the product. There's really only 3 strategies for this particular firm. A is to continue to develop the product and then market the product if it has FDA approval. And B, they can continue to develop the product and then shelve it if it gets FDA approval, or they can just abandon the product. The expected value of strategy A is what? Well, if it continues to develop the product and then markets this product upon FDA approval, the expected value of that is $3.5 million roughly. It's a loss. The outcomes of this strategy are FDA rejected down here, or FDA approved up here. FDA approved is associated with the market being great, the market being fair, and the market being awful. We can develop a risk profile for this strategy. To calculate the risk profile, what we have to do is we're going to come out here on the far reaches of the decision tree. I'm going to calculate the probability of FDA approval and market it in a great economy. In order to calculate that, you need the intersection rule for probabilities. We're going to take the probability that the economy is great and multiply that by the probability of FDA approval. We need 4 decimal places. Now, what I'm going to do is I'm going to copy this. I'm going to put a $sign in front of row 11. Because when I copy this, it will automatically calculate the 2 other joint probabilities. The one for a fair economy and FDA approval and the probability of an awful economy and FDA approval. And then down here, FDA rejected. Well, that's just this probability here, right? 0.1930. The risk profile going from the lowest value to the highest value. This is the lowest value. So this is going to be number one. Of the remaining, which one's the lowest? The next one is negative 5.96. This is number two. And then of these two, the lowest is the negative one, right? This is number three. And this would be number four. So number one, its value is that with a probability of 0.1622. The next highest value is negative. It has a probability of increased at 4 decimal places. And then the third highest value of these outcomes and its probability. And then the highest outcome and its probability. This is what we call the optimal path, also known as the risk profile. According to the table above, the probability of strategy A resulting in a loss is what? Well, anywhere we see a loss, we're going to highlight the probability values. The sum is 0.6385 right there. See that? 0.6385. The probability of strategy A making the company money equals what? Well, it's this loan value here, right? If you notice, when you add these two together, you get 1. The outcomes of strategy B are what? Strategy B, the company can, make the decision to continue to develop or proceed, and then it can make the decision to shelve, right? So there's really only two outcomes. FDA rejected, shelve the FDA approved product. The probability that FDA rejects is 0.1930. The probability that FDA approves is 0.8070. To calculate the expected value of strategy B, we have to multiply this times that, and we have to add that product to this product. Now, notice when we do that, when we multiply this by that, and we multiply this by that, we can factor out this number here, and we end up adding those two together, and we get 1. So the expected value here of strategy B is a negative 5.96 million. The only outcome of strategy C is abandon project. Well, if you abandon the project, the expected value is $0, right? Now, the expected monetary value is going to be the maximum of this value, that value, and that value. And since this is the maximum value, the expected monetary value of the decision tree is 0. And the best strategy is C, abandon the product.